Hey guys, welcome back. Welcome to Vedantu JEE channel, everyone. How are you all? I hope all of you are doing good. I welcome you all once again, guys, and I'm back with another session of JEE 2021. Okay, all those students who are going to appear for JEE next year, or you can say people who are moving from 11th to 12th standard, we are currently taking our JEE syllabus for 12th standard at this particular time. We meet every day. You all are aware about that. Yes or no, guys? So it's a continuation of current electricity, and today we are going to talk about the applications of the device of potentiometer. If you remember, last time we spoke about meter bridge and potentiometer introduction was done, and today we are going to take this forward. And potentiometer as a topic also, I would say, is very important from JEE point of view. So try to pay attention. The applications are not very challenging, and that's why it's fun to solve the questions based upon that and scoring as well. Okay, so let me start off with my introduction as always for people who are new on the channel and attending my session for the first time. So guys, this is me, your Suri Sir, also known as Mogambo on this channel. Why guys? Because when you will crack this examination of JEE, Mogambo khush hoga. Yes. And probably some of you are not even aware about the schedule that we follow for JEE 2021. That means for 12th standard students. So guys, every day at 9 p.m. we discuss theory of physics, chemistry and maths related to JEE. And on 3 days in a week, we solve MCQs. Okay. So on Monday, on Wednesday, and on Thursday we discuss MCQs related to the topics that is ongoing in theory. And along with that, let me also introduce you people to your teachers. This is Harsh Sir. He is your chemistry teacher. This is Arvind Sir. He teaches you all mathematics. And yes, this is me once again, your physics teacher. Okay, guys. So I hope now it's easy for everyone to remember the timing. Very important. Every day at 9 p.m. Definitely you have to be on the channel. And on Monday, Wednesday, and Thursday, you have to be on the channel for MCQ discussion. Okay, people. Also, if you are new and haven't done this yet, then do subscribe to the channel right now and press the bell icon so that whenever any one of us is live, you get the notification. Okay, people. So let's start. And yeah, before we start, there is a very important information that I want to share with all of you, and that is that apart from YouTube, if you are interested in studying on the awesome platform of Vedantu, which we call as Wave, then for that we have an amazing subscription going on for all the students. Okay, so let me tell you in brief that how exactly can you take the advantage of that as well. So this is the link where you will be able to join the platform. Okay, it is available in the description box. So when you will be clicking on it, okay, the name is Vedantu Pro. When you will click on this link, you will be taken to Vedantu Pro's main page, main web page. There you will have to select the standard that you are moving on to. So maybe you are moving to 12th standard. With that, select the exam that you are preparing for. So it could be JEE Main 2022, or it could be JEE Main 2021 for you guys, or NEET 2021 if there is a student from NEET background as well. Okay. Now, what to expect when you join Vedantu Pro? So you will be getting not recorded but live classes from your master teachers, including me, including Harsh sir, including Arvind sir, and many more teachers, guys. Okay, and you will also get assignments and study material from Vedantu, and ample testing and analysis of your own performance. Okay, so as I said, this is how the Wave platform, which I mentioned, the name of the platform is Wave platform. Okay, this is how the platform looks like. This is Pulkit sir teaching in a class. This is where students are able to interact with themselves and with the teachers. And this is the Q&A panel where students are able to ask their doubts. And this is where teacher is explaining a concept live. Okay, it's not recorded again and again repeating. It's a live demonstration and explanation of any concept which is being taught. Okay, guys. So if you are interested in joining, then there are multiple subscriptions possible, either monthly or quarterly, half yearly, or annual subscription. Definitely, if you go for a longer subscription, you will have per month cost reduced accordingly. Okay, and also if you enroll now, then you can avail an additional 15% discount. All you have to do is go on this link which is available in the description box of this video, and there you will have to use the coupon code SMPRO. Okay, if you use this coupon code, then the course the fees for any subscription will get reduced by 15%, and that additional 15% discount can be availed if you enroll on any of the subscription right now. Okay, people, so I hope it's understandable to everyone. Cool. For any queries, you can definitely put your comments down as well. We'll try to get back to you. Okay, so guys, let's go forward and talk about today's topic, that is application of potentiometer. So I hope all of you remember that potentiometer is a device which is a very awesome substitution of voltmeter. With the help of a potentiometer, we can measure a lot of values of potentials without actually deviating from the value which was supposed to be. The problem that we were facing with the help of voltmeter or a meter was that whenever we were connecting a voltmeter or a meter in a circuit, we were fundamentally adding more resistance to the circuit, which was actually deviating the value which we were actually intending to find out. But potentiometer, because it works on null deflection method or null point deflection method, okay, so because of that null point method, there is no current which flows through the galvanometer which is connected in the device of potentiometer. So that's why the readings are fairly accurate when we are using this as a device. So let's see the main applications that we are going to study here. So basically there are three applications that we study. First is to find the EMF of an unknown battery. So say in your house you have a battery which you have kept for a long time, but now you are not aware whether you should be able to use this battery for a particular requirement of voltage or not. So you want to basically check how much is the voltage of the current battery that you have in front of you. So with the help of potentiometer device, you can do that. Secondly, you can compare any two batteries, their EMF, which one of them is stronger and which one of them is weaker. And also you can find out the value of the internal resistance of a battery. Okay, so let's go one by one and try to find out the value of all these unknown values that we are interested in. Okay, so guys, the first thing is to find the EMF of an unknown battery. So if you remember, this is the primary circuit of potentiometer device, and this part is the secondary circuit, right? So in the primary circuit, we know that there is some current which was already flowing when the key was not closed in the secondary circuit. So secondary circuit is open in the beginning, and maybe some I current is flowing here. Okay, so when I current is flowing here, because of that, there is some potential drop which will happen on VAB. So VAB can be found as I into RAB, and if we get the value of VAB, we can find out the value of the potential gradient, right? So if we define the potential gradient to be, say, lambda, I know we wrote it as x last time, but it's okay, you can write it as lambda also. So lambda is going to be the total potential drop on wire AB. Yeah, this is wire AB divided by the length of that wire AB. So if I say that the total length of the wire is capital L, then dividing the total voltage drop, potential drop on that wire by the length of the wire is giving me the value of potential gradient. Now, when you connect the secondary circuit, you basically take this jockey J and you make it move on left or right side, or without actually sliding it, you keep on touching it at different points from here to here. So when you are doing that, maybe at this point, you find the balancing point here, say maybe at a length L. Okay, so what exactly is the value of balancing length? It's something which is fairly measurable on the scale over here. So when you get the value of L, what exactly happens there? The current which was flowing in the secondary circuit, which is basically IG, it becomes zero. Yes, the current flowing through the galvanometer becomes zero, which means secondary circuit now has no current. But definitely if there is no current flowing, then this point also becomes A and this point also becomes J. So VAJ, which in the lower branch is nothing but the value of the battery potential, and VAJ in the wire is nothing but lambda into L, because lambda value is constant. We already know that I current is still flowing when there is no current flowing in the secondary part of the circuit. Then we can say that E1 is nothing but lambda L. So this is how we are able to find out the value of the unknown EMF E1, and we can simply from here also comment that this E1 is proportional to the balancing length. Means what? More be the potential of this unknown battery, more be the balancing length. Okay, and that is where it will give us a breakthrough to go and talk about the second application, and that is where we talk about the comparison of EMFs of two cells. So say you have this cell E1 and the other cell is E2, and when cell E1 was connected, maybe the balancing length was coming out to be L1, and when E2 will be connected, the balancing length will come out to be L2. So we can say that very simply, E1 should be equal to lambda times L1, and when E2 is balanced, it comes out to be lambda times L2. So can I say that just by taking the ratio E1 by E2 is going to be lambda L1 upon lambda L2, and because lambda is safe for the wire AB, that's why the final result can be simply said E1 by E2 is equal to L1 by L2. Okay, people, so please keep this result in mind if you can, because not a very challenging result to keep in mind, and it'll help us solve a few questions if it comes across. Okay, now comes the application which I consider is the most challenging one, the third one. Okay, this is the third application for us from potentiometer, is to determine the internal resistance of a cell. So you remember that this is your primary circuit, and this entire part is your secondary circuit, right? So in the secondary circuit, uh, initially the key K dash is open, and in primary circuit we already know the value of lambda. So if you have the part first when K dash is open, then we can say that it is E which is getting balanced, this E, and that will be balancing at some length L1. So we can say that E is equal to lambda times L1, just as we were talking about finding the EMF, unknown EMF of a battery. So here we already, when we have kept K dash open, key is open, so only this part is behaving as your circuit, secondary circuit. So E and R dash are connected, but because this key is open, so there is no current IG which is flowing in the galvanometer, so no current is flowing through R dash as well, and R dash is the value that we are actually interested in. Okay, so now what you are going to do, you are going to basically close this key. So once the key gets closed, the circuit has got imbalance. So because of that, now the balancing point has to be shifted, because of the connection of R dash, the resistance in the secondary circuit has changed. Now R dash has become a part of the circuit, secondary circuit. So value of IG will obviously, become non-zero. So you will have to displace this J to maybe get the value of new balancing point, which is say length L2. So now again when this has happened, that Ig has become 0. So in this branch, this point has to be J again, this point has to be J again, similarly these two have to be A again. Now what has happened in this circuit, the secondary circuit, you have some I dash current which again starts to flow. Yes, there is no I dash Ig going over there, but we have I dash which is flowing in the secondary circuit, which I can say that I dash is going to be E divided by R dash plus small r dash. Yeah, because now this is behaving like a circuit which has one battery and two resistances. And can I say that VAJ is going to be I dash into R dash and is also equal to lambda into L2. So for this part, the topmost part AJ and the bottommost part AJ, you can actually use this middle branch also, not a problem at all. So I'm choosing the AJ at the wire AB and the other AJ branch as the bottommost branch here. All the three branches will have the same potential when no current IG is flowing here, and no current will be flowing in this A to A dash also. A to A. Okay. So I dash is E by R dash plus small r dash into R dash equal to lambda L2. And what is the value of E, guys? We already have found the value of E. Let's put that. So that is lambda L1 upon r dash plus small r dash into r dash equal to lambda L2. So lambda gets cancelled. Okay, and what do I have here is I'll bring L2 here in the denominator. So L1 by L2 into R, and on the right side I will have R dash plus r dash. So L2 by L1 by L2 r dash equal to r dash plus small r dash. Bring this r dash on the left hand side, and now r dash value, the internal resistance which we are interested in finding, becomes r dash L1 by L2 minus r dash. So I can take r dash common, and I have L1 by L2 minus 1 as the value of the internal resistance. So if you rearrange this value, this is what we are going to get. This is the result of internal resistance of the battery that we were interested in finding the internal resistance of. Okay, this is the internal resistance r dash that we are interested in finding. Okay guys, so that value comes out to be L1 minus L2 upon L2 into r dash, where L1 is the original balancing length when key was open, and L2 is the balancing length when key K dash gets closed. R dash is this resistance which is connected in the secondary circuit. Okay guys, so I hope these three results are easy for us to remember. This was the first result. When batteries EMF is to be found, it is just equal to lambda L. When we are comparing the two batteries, their EMF, then it is simply the ratio of their balancing points length. And when we are finding the internal resistance, it is L1 minus L2 upon L2 into R dash. It actually tells you that L1 will always be greater than L2. That means before key K dash was connected, the balancing point length was more, and then after that the jockey will move to the left side. Okay, cool. So guys, let's try to solve a few questions here. We have this first question which says that a potentiometer with 1.45 volts cell is connected for finding the internal resistance of 1.2 volts cell. Okay, and the balancing point corners at 65 centimeter. So if we have initial key being opened, or this 10 ohm was not connected, so the balancing length was coming out to be 65 centimeter. Okay, and we are interested in finding the internal resistance here. So if we have now this 10 ohm connected, the new balancing length comes out to be 55 centimeter, and the value of r that you are connecting is 10 ohms. So question is to find out the value of small r, and small r is going to be L1 minus L2 upon L2 into capital R. So L1 is 65 minus 55 divided by 55 into 10. That comes out to be 10 by 55 into 10, or simply 100 by 55. So if it would have been 100 by 50, then answer would have been perfect 2. So it is going to be little less than 2 value. So this value will come out to be 1.818, or simply 1.82 ohms. According to the options, option B is the correct answer for us. Okay, everyone? Cool. Now this one, it says that in a potentiometer experiment, the balancing with a cell is at length 240 centimeter, and shunting the cell with the resistance of 2 ohms, the balancing length will become 120 centimeters. So we have to find the internal resistance again. What is given to us is L1 equal to 240 centimeter, and L1 is 240 and L2 is 120 centimeters. So internal resistance value will be L1 minus L2 upon L2 into capital R. So this is nothing but 240 minus 120 upon 120 into R, that is 2 ohms. So this comes out to be 120 by 120. So simply the ratio comes out to be 1 into 2. So internal resistance also comes out to be 2 ohms, and our answer becomes option C. Okay guys, cool. Moving on to this one, this says that in a potentiometer, a cell of EMF 1.5 volt gives a balancing point at 20 centimeter length of the wire, and another battery gives the new balancing point at 60 centimeter. So we have to find the EMF of the battery. So if you remember, if we are comparing the EMF of two batteries, then E2 by E1 should be equal to L2 by L1, where L2 and L1 are the balancing lengths respectively. So E2 will be equal to L2 by L1 into E1. So L2 value is 60, L1 value was 30, and the originally used battery was 1.5 volts. This cancels 2 times. So E2 is 2 into 1.5, that is simply 3 volts. Okay, that means the answer comes out to be option A. Okay. Okay guys, let's try this one. Now this says that the balancing lengths of a potentiometer wire are 800 centimeter and 600 centimeters. Okay, so when the two cells of EMFs E1 and E2 are connected in secondary circuit, first in series and then the terminals of the two cells is reversed. So if you talk about the secondary circuit where the balancing has to happen, earlier in the secondary circuit you had the two cells connected like this. This is the secondary circuit I'm talking about. This is where your potentiometer is. So this was E1 and this was E2. So earlier what you were getting was E1 plus E2. You were getting the balancing length as 800. Okay, that means I can say it is lambda into 800. Okay, after that we are given that in the same circuit now the balancing length has changed because you have changed the polarity over here. Okay, so that means now this is E1 and this is E2 but with a polarity changed. So we can say that this has become E1 minus E2 and this time the balancing length is coming out to be 600. Okay guys, so let's do one thing. Let's take the ratio of these two. So when we take the ratio, we get the ratio on the right hand side as 8 by 6, or we can say that the value will come out to be 4 by 3. Yeah, because lambda gets cancelled, zeros gets cancelled. So we have 4 by 3. Let's cross multiply. I have 3 E1 plus 3 E2 equal to 4 E1 minus 4 E2, and question is any which way asking for E1 by E2, so we don't need to find out their individual values. So I will take this 3 E1 to the right hand side and I will bring this 4 E2 to the left hand side. I will have 4 minus 3 as 1 E1 and 4 plus 3 becomes 7 E2. That means E1 by E2 comes out to be 7 is to 1. That means our answer comes out to be option C. Okay guys, awesome. Now this says that the potentiometer is used for the comparison of EMFs of two cells E1 and E2. For the cell E1, the no deflection point is obtained at 20 centimeter and that for E2 it is obtained at 30 centimeter. So very simply we have to just tell the ratio of EMFs. So we can say that E1 by E2 is going to be L1 by L2, which is 20 by 30 or simply 2 by 3. Okay, just for our practice, easy question, answer comes out to be option A. Okay, now this says that in an experiment to measure the internal resistance of a cell by potentiometer, it is found that the balancing point is at a length of 2 meter when the cell is shunted with 5 ohm resistance. Okay, and it is coming out to be 3 meters when the cell is shunted with 10 ohms resistance. So we have to find out the internal resistance only. We know that R is going to be L1 minus L2 upon L2 into capital R. So this R is going to be, say, some value which was there when none of these resistances were connected. Okay, none of 5 ohm or 10 ohm was connected. Then what was happening, the value of balancing length was coming out to be L. So when I connected 5 ohm, the balancing length came out to be 2 meter. So L2 becomes 2 meter and resistance is 5 ohms. Same internal resistance will be the value when the resistance externally parallelly used is 10 ohms, but the balancing length becomes 3. Okay, are you getting it guys? So L2 in case of R value being 5 comes out to be 2, and when you use R value as 10, L2 comes out to be 3. So this 5 will cancel this 10 two times, and if I cross multiply, I have 3L minus 6 equal to 2 and 2 multiplies to become 4 gives you 4L minus 12. So that comes out to be L equal to 6 meters. So this was basically the balancing length when none of the external resistances were connected. So now internal resistance can be found as, say, L minus 3 by 3 into 10. So L value is 6, put that value. What do I get? 3 by 3 gets cancelled. The answer comes out to be simply 10 ohms. So our answer of the internal resistance of this cell, which has been connected with two different external or shunt resistances as 5 and 10. Okay, cool. Now this says that we have a battery of EMF 12 volts and external resistance connected as 10 ohms, and another wire which has its own resistance RAB connected in series with this wire. That is basically your primary circuit. And in your secondary circuit, you have two batteries with E1 equal to 2 volts, R1 equal to 2 ohms, E2 equal to 4 volts, and R2 equal to 6 ohms. Okay, so question is asking us to find out the value of the distance of point N, that means the balancing length L is to be found when there is no galvanometer current flowing through it. So let's do one thing. When we talk about this, let's find out what is happening in the secondary circuit. If we find out the E net value, then that is going to be E1 by R1 minus E2 by R2 here. Or let it be plus only, but the polarities are different, so we'll put one of them as negative, divided by 1 upon R1 plus 1 upon R2. So E1 is, say, 2, its resistance is 2. This is minus because polarities are opposite. They are trying to oppose each other in this case. So E2 will be equal to 4 divided by the resistance, that is 6, and this is 1 by 2 plus 1 by 6. So when we simplify this, this comes out to be 6 minus 4. When you take the LCM, this comes out to be 6 minus 4 divided by 6, and the other denominator is going to be 4 by 6. So when I cancel this, I get 2 by 4 or simply 1 by 2 volts. Okay, so E equivalent value of this comes out to be 1 by 2 volts. That means what? These both can be replaced by a single battery with some internal resistance as ER, and ER came out to be 1 by 2 volts. Okay guys, now why am I not finding the value of this R equivalent is because when this galvanometer have no current flowing through it, then internal resistance will any which way not draw any current, or any voltage will not be dropped over it. Now let's try to find out the value of the current which will flow in the primary circuit here. So for finding that value, I will require the EMF value which is given to us as 12. This value is 8. Okay, so this is total voltage, that is 12 divided by the resistance. So to find the value of resistance of this wire AB, what is given to us that its resistance per unit length is 4 ohm per meter, and the total length of the wire is 4 meter. So RAB comes out to be the value of resistance per unit length multiplied by the length. It comes out to be 16 ohms. Okay, so that means the total resistance is 8 plus 16, that is 20. So this is the value of the current that we are getting. Sorry, 16 plus 8, that is 24 in fact. Yes, this value is 8. Okay, look at this. Okay, so we get it as 12 by 24 or simply 1 by 2 ampere, and the value of potential drop on this wire VAB will be equal to I into RAB. Current is half, RAB is 16, so this value is 8 volts. So out of the 12 volts of that battery on AB, 8 volts are getting dropped. So lambda value comes out to be VAB by length of AB, and VAB is 8 volt, its length is 4 meters, so it is 2 volt per meter. Now when this battery is getting balanced for a length L, we can say that ER will be equal to lambda L, and L will be equal to ER by lambda. Okay, so ER we already found it here. This value is 1 by 2 volts divided by 2 volts per meter, so it is 1 by 4 meters as the answer that we get, or you can say 25 centimeters. From the left hand, we get the answer as option D. Okay guys, so what we did, we first simplified the secondary circuit. There we got the value of net EMF as 1 by 2 volts. Both the batteries are trying to send the current in such a way that they are going to oppose each other. This will send the current here, and this will send the current in the opposite direction. That's why net EMF, when I'm finding, I've taken a minus sign here. Found the value of net EMF as 1 by 2 volts. Found the resistance of this wire came out to be 16 ohms. Then we found out the value of the current that is flowing in this primary circuit. Okay, that came out to be half ampere. Found the value of potential drop on AB, which came out to be 8 volts. Found the value of lambda, which is potential gradient, so that came out to be 2 volt per meter. And then got to the balancing length, which comes out to be 1 by 4th of a meter, or simply 25 centimeters. Okay guys, so this is the application part of potentiometer along with the problem solving. Do try to solve the questions by yourself as well, and if you are the student who has missed the previous session of this chapter or the one which were done before that, then how can you cover up the topics which I have already done? For that guys, all you have to do is go on the channel playlist, and in the channel playlist all you have to do is look for this playlist JEEt Lo 2021. You will find all the lectures of physics separate, chemistry separately, and mathematics separately. Okay guys, cool. Also, if you are a student who is preparing for JEE 2020, then for JEE 2020, we have a crash course which is running where we are giving away 90 plus live sessions, 20 plus comprehensive tests, your own performance analysis, and rank booster quizzes during the sessions, and many more things are being given to the students here. Okay, and if you are interested in joining the crash course, all you have to do is go on this link, follow this in the description box or in the comment section also. You will have to click over there and it will direct you to the link of the web page, and there you will have to use this coupon code SMCC, because if you'll use this code, the course fees which is worth rupees almost 25,000, this will be yours for just under 3,500 rupees. Okay, so this is the crash course. And one more thing, yeah, if your examination gets postponed, if JEE examination gets postponed, then in that case the course will be yours, as in you will still remain the student of Vedantu for this course. You will stay enrolled till the time your examination happens. Okay, so even if the exam gets postponed, you will still be a part of the crash course and you will continue your JEE prep with us in the same batch. Okay people, this is one thing, that is crash course. And say if you are interested in just the test series, then we are giving away 10 FLTs, full length test, which is obviously online mode, which is the mode of JEE examination also. You will get live test paper discussion by master teachers and unlimited doubt solving sessions. Okay, so if you are interested in this test series, then test series can be enrolled for by using this link, which is available in the description box and in the comment section as well. But this time you'll have to use the coupon code SMTest. So the test series, which is worth rupees almost 10,000, could be yours for just 1399. Same thing applies here as well. If you are part of this test series, which is targeting JEE 2020, then in case the exam gets postponed, you will still stay the student of Vedantu till the time your examination is conducted. Okay guys, so I hope things are clear and understood by everyone, that even if the exam is getting postponed, you are still becoming and remaining the student of Vedantu till the time you appear for the examination. Okay. Also, if you are interested, then you can join our Telegram channel where we give away the assignment solution, study material, and daily update. For that, this is the link which is also available in the description box of the video. So click on that and join the Telegram channel and be a part of Vedantu family from there. Okay. So guys, if you enjoyed solving questions with me related to potentiometer and you enjoyed the session itself, then show me that by pressing the like button over there. Okay, also share with your friends, let them also study along with you. And if you have not, then subscribe to the channel and press this bell icon so that whenever your Suri Sir, your Mogambo comes live, you get the notification. Okay people, so with a promise to see you all next week, I will take your leave now. Till then, keep studying, keep enjoying your studies with Vedantu, and do enjoy your weekend. See you all, take care, bye bye.